Welcome to our data science basics class. Today we will deep dive more into statistics and we will cover more statistical topics. Let's start with variance. Now, most important question is what is variance and what is the importance of variance? Variance is very important tool in understanding the data, the spread of data, and it is actually denoted by sigma or squared S, right? Or S square, where S is standard deviation. I will cover standard deviation later. Now, before understanding variance properly, we have to understand what is mean. Now, mean is actually, you can say, like heart of your data. The mean gives us central point, helping us understand where our data is centered. Now, variance. If the mean is the heart, variance is the soul of the data. Variance tells us about spread or scale of our data. It measures how much data point differ from the mean. A high variance means the data points are spread out widely, while a low variance indicates they are clustered closely around the mean. Now, what is standard deviation? Standard deviation is denoted by simple sigma. This is the square root of variance. It's more intuitive measure of spread because it's the same unit as our data, unlike the variance, which is in squared units. In essence, while the mean tells us where our data is, variance and standard deviation tells us how our data behave around the center point. This understanding is crucial for interpreting data and making predictions in data science. Now, let's explore variance in depth and let's understand variance using examples and using graphs. First, we find the mean of all our data points. In statistics, we often use the symbol mu to represent this mean. It is calculated as mu equal to expected value of x. To find the variance, we calculate the average of squared distances of each data point from the mean. Squaring these distances makes us sure we are looking at how far away, on average, each point is from the mean, regardless of whether it is above or below the mean. The formula for variance symbolized by sigma squared. This is shown as sigma square equal to expected value of x square minus expected value of x whole square. Here, expected value of x square means we first square each data point, then average these squared numbers. Expected of x whole square is just squaring the mean of our data, right? By subtracting these two, we get the variance. This tells us the average square distance from the mean for our data set. Now, let's understand using an example. Let's consider a discrete case. Let's consider a discrete example to understand variance. Suppose we have a small set of data points representing the number of books read by a group of students in a month. Let's say the data is as follows. Students A, B, C, D, E. Number of books read 1, 3, 3, 4, 5. Student A have read 1 book. Student B have read 3 books. C have read 3 books. D have read 4 books. E have read 5 books. Now let's calculate the variance of this data. Step 1. First of all, we need to compute the mean. So the mean or average number of books read by the students is mean equal to sum of all books read divided by number of students, which is equal to 1 plus 3 plus 3 plus 4 plus 5 divided by 5 equal to 16 divided by 5, which is 3.2. Now second step is calculate the variance. Variance is the average of squared differences from the mean. So we do the following for each data point. Subtract the mean from each data point. This gives us difference from the mean. Square each difference. This makes sure we are looking at distance regardless of whether it is above or below the mean. When we say below or above the mean, it means if the independent or each value is above the mean or it is below the mean, right? And average these squared differences. Now let's calculate it. Variance is equal to sigma square equal to 1 minus 3.2 whole square plus 3 minus 3.2 whole square. 3.2 is mean, remember? Plus 3 minus 3.2 whole square plus and so on. If we compute this calculation, we get 1.76. So the variance of number of books read by these students is 1.76. This value tells us on average how much number of books read by each student deviates from the mean number of books read. This is actually here you have converted a statistical concept to a theoretical concept. Now let's take another example where we compute the variance for continuous variable. For continuous case, let's consider an example involving the heights of a group of people. Imagine we have height in centimeters of a population measured continuously over a certain range. For simplicity, let's say we have following height data: 160 centimeter, 162 centimeter, 165 centimeter, 167 centimeter, 170, 172 and 175 centimeter. We will calculate the variance for this continuous data set. Again, step 1, we need to compute the mean. First, we find the mean height of the group. Mean is equal to sum of all the heights divided by number of people. So numerator will be 160 plus 162 plus 165 and so on, divided by 7. Simplifying it, we get a mean equal to 1171 divided by 7, which is equal to 167.29 centimeter. Now calculate the variance. The variance is the average of square differences from the mean. We follow these steps. First of all, subtract the mean from each data point to find the difference from the mean. Square each difference, find the average of these square differences. Let's calculate and simplify. Variance equal to sigma square equal to 160 minus 167.29 whole square plus 162 minus 167 plus 29 whole square and so on. Simplifying it, we get 175.4287 divided by 7, which is equivalent to 25.06 centimeter square. So variance of heights in this continuous data set is approximately 25.06 centimeter. This value represents average square deviation of each individual height from the mean height of the group. Now, next natural concept after the variance is discrete probability distributions. Discrete probability distribution describes the probability of occurrence of each value of a discrete random variable. Discrete random variable can take only a countable number of distinct values. Common type of discrete distributions are uniform distribution, Bernoulli's distribution, binomial distribution, Poisson distribution, geometric distribution. Let's understand each distribution one by one, but before proceeding for individual distribution, let's have a small snapshot about these distributions. First is uniform distribution, where all outcomes are equally likely. Second is Bernoulli's distribution. It models random experiments that have exactly two outcomes: success or failures, associated with probabilities P and 1 minus P. Third is binomial distribution, deals with number of successes in a fixed number of independent Bernoulli's trials, like flipping coins. Poisson distribution, useful for modeling the number of times an event occurs in a fixed interval of time or space. Next one is geometric distribution, concerned with the number of trials needed to get the first success in repeated independent Bernoulli's trials. While taking these lectures, I suggest you guys to keep on taking notes and go through these notes over and over again. It will actually help you understand this concept better.